that I gave you. The exam is going to cover 11 to 21. I'm going to just go through some of the topic over here, and I will jump to some of the questions related to the topic. So I'll give you the answer for the sample question I give you in the review sheet. So the first topic that we talk about for this exam is about the matters. So we start by giving like atomic model. So you should know each one of the atom contains 3 different things, and they're like proton, a neutron, and electron. The proton, we use P positive to represent. The neutron is the N0, and the electron is the E minus. So electron carry negative charge, neutron carry a neutral charge. If there's no charge at all, proton has a positive charge. We also make a table to show you the difference, right? So which one has more mass, which one has less mass. So electron is much lighter than the rest of them. The size of the atom actually itself is very small. However, if you look at the inside of the atom, most of the space of the atom is empty because electron is even smaller than the atom itself. And proton and neutron, they concentrate at the center. So if you draw a model of the atom, this is your electron, and this is going to be your proton with the neutron, which is a nucleus. So most of the space are empty. We also talk about certain different terminology about the ion. So ion is a charged atom. It loses some of the electron, or it will gain some of the electron. And if they actually gain the electron, and there will be a negative charge. If they lose the electron, will be the positive charge. That is the ion. Isotope is one of the important idea. The isotope meaning you have the same number of the proton but the number of the neutron is different. That's what we call an isotope. One of the questions that we ask you in the simple question is, can you give some example of the isotope? And we use the helium to represent it. So let me just make a notation what the isotope for the helium could be. So helium, if you have the chance to look at the periodic table, helium is the second element in the periodic table. How do we know which one is the second, which one is the first? You look at the number at left lower corner. This number represents what is the number of the proton. There's another number on the left upper corner, which is this number. This number represents the number of proton plus the number of neutron. So if you have 4, that means you have 2 proton, you have to add another 2, which represent the number of the neutron. So in this helium, it has 2 proton, it has 2 neutron. At the same time, in nature, we also have another helium, which is symbol is 2 and 3. And the 3 tells you the number of the neutron will be only have 1. So this only have a 1 neutron, and the other one has a 2 neutron. And these 2 elements are what we call the isotopes. They are all helium, but they have a different number of the neutron. So that's the definition of the isotope. Molecule and the compound and mixture are are all composed by several different elements. And the most important thing is that you have to distinguish what is the molecule and what is the mixture. So the molecule has a chemical bond. The mixture doesn't have a chemical bond. So that's the main difference of these two. For chapter 12, the solid, we first give you the definition of the density. So let me write down what the density is depends on. Anybody know what the density depends on? So it depends on the mass. It also, yeah, it depends on the volume. It's proportional to the mass. So if you have fixed volume, you have a more mass, meaning it's more dense. If it's a larger volume and with the same amount of mass, that means it's a less dense. So it's inverse proportional to the volume, but it's proportional to the mass. The density is the property that we describe for the solid. Another important property about the solid is how much it is elastic. There's a law called the Hooke's law. The Hooke's law is for the elastic material. When I say elastic, meaning if you deform an object and if you release the force, it will come back to what it was. And this is what we call the elastic. The deformation is only like temporary. It will go back to what it was. If the deformation is permanent, that's what we call the plastic. So, or inelastic. So elastic is a property, it will go back to where it was. Now the Hooke's law tells us if you apply a force, it's going to extend longer or it's going to compress shorter. And it's proportional to how much of the force that is. So if you give more force, it's going to give more change of the length. That's what the Hooke's law is. We can apply the force in two different ways. You can give extension. You can give it like a tension. So tension meaning you have something over here, you pull it outwards. That's the tension force. You also could have a compression. So the compression meaning the force is against the object. So that's the compression force. You can give this kind of force from the sideway as well. If you give the force on the sideway, then if this is the force, then the bottom is going to have a tension and the top will get a compression because they deform, and then you're going to see the bottom is going to get longer. It gets longer because of the tension force, but the top is going to get shorter because it's going to have a compression. So that's about the solid. And the next one is going to be the liquid. We talk about a lot of things about the liquid. The most important thing is that we start with the definition of pressure. We have two different ways to define the pressure. So you can use the force over area to get the pressure. You can also use the density times the depth. These two are the two different ways we can define the pressure. And most important is how do you look at the pressure difference is actually depends on the depth difference. Direction of the pressure, well, is always perpendicular to the applied surface. It's not a vector, but the direction is always perpendicular. This small symbol that I use is perpendicular. So always perpendicular to the surface. That's the direction of the pressure. Buoyant force and Archimedes principle are important. So we spend a lot of time discuss about this. So the buoyant force is due to the depth difference. we make a drawing on in the lecture. So if you have a block inside of the liquid, so this is liquid, and you know the pressure on the top is less than the pressure at the bottom because the depth is different. So this force, this pressure force is going to be larger than the pressure force at the top. That's where you get the buoyant force. The difference of these two forces give you the buoyant force. The side force, because they are at the same depths, they are going to be the same and they can cancel out. So the side force they are the same amount with a different direction, so they will cancel out. But the top and bottom give you the buoyant force. The buoyant force is going up because the bottom is larger than the top. So that's the buoyant force. The Archimedes principle is important. The Archimedes principle tells you the buoyant force is equal to the weight of the displaced fluid. So that's Archimedes principle. Okay, about the flotation. So we talk about different situation in the fluid. You have to look at that. What is the volume to be displaced if they are sink into the water, and that will be related how much of the buoyant force that is. A simple rule about a float and sink object is this. So when you have something float, meaning the buoyant force is larger than the weight or equal. When you have the sink, then meaning the buoyant force is less than the weight. So it's heavier, so it sinks to the bottom. That's the simple rule about that. And we also talk about what is the buoyant force in a different situation. Now, let me make this one smaller. So if you have a floating object, and this meaning the buoyant force is actually equal to the weight. When you have the sink object, the buoyant force is equal to displaced fluid weight. So that's the simple conclusion based on the Archimedes principle and the buoyant force, and to look at this one for the floating object or the sinking object. So that's the way you can determine whether things will be float or will be sink and how the buoyant force is. Okay, any questions so far? We're good. Okay, now air pressure is similar to the fluid pressure. They all depends on the density and the depth, and air will also give you buoyant force as well. One of the important property about the gas is the Bernoulli principle. So what is the Bernoulli principle? Bernoulli principle tells you if you have a fluid as a moving with a higher speed, and then what happened to the pressure? If you're moving with a higher speed, the air moving at a higher speed is going to have a less pressure. So that's the Bernoulli principle. We show you some of the demonstration using a ping pong ball brought by the air dryer. That's the one example of the Bernoulli principle. If you driving a car and the two cars passing with each other, you're going to have a higher speed of the fluid in between, and you're going to have like attraction of the two vehicle toward to the center. So that's the same idea about the Bernoulli principle. The chapter 15, we started to define the heat, temperature, and internal energy. So you have to know the two different ways that we define the temperature, right? The temperature is, in the microscopically, is the average translational kinetic energy per particle. That's our definition of the temperature. The material doesn't have a heat, it has a temperature. The heat is the energy in motion, so you have to know the difference between the heat and temperature. Itself is not energy, it's simply just energy is moving from one place to another. The unit for the energy is calorie or joule. So that's internal energy is related to the temperature. Higher of the temperature, you have a higher of the internal energy. Internal energy also depends on the amount. So more of the amount is going to have more of the internal energy. Thermal expansion, I didn't spend a lot of time talking about the thermal expansion. So this is a kind of like an interesting topic. Thermal expansion has a phenomenon. So if you, in the book, they tell you one of the experiment you can actually do by yourself. If you puke your mouth, make your mouth smaller, you blow air to your hand, you're gonna feel the air is colder. But if you wide open your mouth and you blow air to your hand, you're gonna feel that the air is hotter. So why would the air from your lung is going to make difference if you change the shape of your mouth? Well, it's about the thermal expansion. So when you wide open your mouth, the air pressure is about the pressure of the outside. So there's no expansion for the air at all. And in that case, whatever the temperature of the air from your lung is going to be the temperature that you feel on your hand. And because the human body has a higher temperature than the outside air, so your hand is going to feel warmer. However, if you puke your mouth, you create like a nozzle. So what happened is you're going to compress the air inside of your mouth. When the air go outside of your mouth, it's going to expand. And the result of the expansion is it is going to take away some of the energy from the outside. And you're going to feel colder. So expansion is actually what we call the cooling process. When the air starts to expand, it's going to take the energy from the surrounding area and you're going to feel colder. One example is that, you know, there's like some of the compressed bottle, like you used to clean those dust. And when you compress, when you press the button, the air will release from the bottle and you're going to feel the bottle getting colder because it's an expansion of the air from the inside to the outside. And the result of that is going to take away some of the energy from the outside. So thermal expansion is a cooling process. That's the thermal expansion. Specific heat is a property to tell how fast or how slow and material will change its temperature. So so if you have a small value, the specific heat is the capital C. Smaller C represent it's going to change temperature faster. If you give the energy, it's easier to change its temperature. So the smaller C is going to easier to change the temperature. The higher C, meaning you need more energy to change it. That means it's harder to change its temperature. So that sometimes we also call this like energy inertia. It's like more of the mass is harder to make it move. So you have a higher of the thermal heat capacity, meaning it's harder to change its temperature. The heat transfer, we talk about heat transfer. There's 3 different ways of the heat transfer. Conduction, meaning direct contact. Convection, meaning the fluid motion. Radiation, meaning is a radiant energy from a wave. So these 3 important mechanisms you have to know which is which. The conductor insulator, meaning conductor is easier to transmit the heat. The insulator is harder to transmit the heat. In the class, I show you, I tell you to touch different material and you feel different. Was because the conductivity of the thermal energy is different for different material. We also mentioned about the greenhouse effect. So the greenhouse effect is due to the media will prevent the wave to radiate. So it's about the radiation, it's about the different media will allow transmission of certain kind of a wave. If you increase the heat and the radiation normally is going to increase, and the normal temperature is going to give you a radiation of the IR range. So it's an IR wave. And the IR wave is going to increase the temperature. If we cannot allow the IR wave to move, to transmit, then you're going to have a greenhouse effect. So there's like a simple version of the greenhouse effect. After the heat transfer, we talk about the change of the phases. We talk about different thermodynamics law. So what is the change of the phase means? If you want to change the phase, say for example, you want to change it from the solid to liquid, and you need to give energy. So you need to absorb energy. If you change from liquid to solid, then you're going to release energy. Okay, certain place when you change the phase, you're going to take energy. But if you are if you are just at the same phase, you give the energy, it's going to change temperature. So change temperature, you need energy. You either give or take the energy away. Change phase also need energy. So those energy is what we call the latent energy. Cooling and warming process. These 2 are important process. It depends on what kind of a situation that you have. It's opposite to what we think. So if you go condensation, so what kind of process would that be? And if you go evaporization, what kind of process would that be? So cooling, evaporization is the cooling process. Condensation is a warming process. The entropy, so if you don't remember that, just review those topics. Entropy and disorder. So entropy is a way that we measure order or disorder. Entropy, normally in nature, we tends to be more disorder. So in nature, it's going to be more disorder, and entropy is a measure of disorder. For the thermodynamics, you just need to know like simple idea what the thermodynamics law represent. The zeroth law represent the thermal equilibrium. Two objects, you put it together, they will reach to the same temperature, is what we call the thermal equilibrium. The first law is about the conservation of energy. That means if you give the energy, this energy will become an internal energy or it will do some work. So that's the first law of the thermodynamics. The second law tells you how the energy will flow. So energy will flow from high temperature to low temperature. So these are the three different thermodynamics laws. One important thing about the vibration and the wave is that you need to know what are the definition of each one of these and what are the two types of the wave. We just talk about these two types of waves, so I'm going to skip this part. Let me just quickly make a drawing to show you what all these things represent. So a transverse wave is the way we describe what a wave is. The height of this from the neutral place is not from the bottom, but from the neutral place is what we call the amplitude. It tells you how big or how small the wave is. If you look at from the peak to peak or from the bottom to bottom, and the distance of this is what we call the wavelengths. The time required to finish to complete one cycle is called period. So frequency is reciprocal to the period. It's 1 second how many cycles that you can do. So that's the frequency. So frequency, wavelengths, period, amplitude, these are the most important property that we describe a wave. Interference, we just talked about that. Standing wave, meaning the wave, a certain place in the wave is not going to move, and that's the place what we call the node. Doppler effect is that this is also an important property about the wave. If the source or the receiver if you have a wave, you have a sun, and it's the source of that is moving, then you're going to hear different frequency. If it's toward to you, and you're going to hear a higher frequency. As it getting away from you, it's going to have a lower frequency. Same thing if you're running toward to the wave, to the sound source, you're going to hear a higher frequency. So closer between the source and the receiver, you're going to have a higher frequency. If you're getting longer and longer, you're going to have a lower frequency. Okay. Any question about the material that we just did about the review? Are you guys still with me?
No questions for me.
Okay.
I'm clear too. Thank you.
No questions.
All right.
No questions so far.
Okay, great. Okay, so let me just go through this simple question over here. Some of them I already answered it when we do the review. Unless you have a question, otherwise I will just briefly tell you what I did before. So the first one asking for the isotope of helium. I just draw two of the helium on the top. Hooke's law, meaning the length of the spring is going to proportional to the force that you apply to that. So that's the Hooke's law. It's about an elastic material. So this is about the elastic material, not for the inelastic. So elastic meaning it will go back to where it was when you release the force. With the water pressure greater 1 meter below the surface of the fresh water or 1 meter below the swimming pool at the same elevation. To answer this question, you have to know how we define pressure. So pressure, two definition, force, divide the area. The other one is the density multiplied with the depth. Two situations, one is the lake and the other one is the swimming pool. Both of these are the fresh water, so their density is the same. What about the depths? Well, it's 1 meter below, and the other one is also 1 meter below, so they are the same depths, so they should be the same. So their pressure should be the same because the density is the same, depth is the same. Number 4 is the buoyant force. So you have 100 pounds of a raft floating across a lake. What is the buoyant force? Is it going to be greater than 100, equal, or less? And if you go back to how we define the floating or sink object, if things is floating and the weight is equal to its buoyant force. So buoyant force is actually equal to 100 pounds. If it sinks to the bottom, then the buoyant force is going to be less than its weight. It's going to be smaller than 100 pounds. Okay, definition of temperature, I already talked about that. Definition of the internal energy, we told you it's going to depend on the mass and also depends on temperature.
Dr. Liu,
Yes.
for sample question number 4, you said, okay, the raft floating across the lake is 100 pounds. So the buoyant force applying to that raft, it's 100 pounds. It's equal, right? That's why it floats, correct?
Yeah, it's equal, yes. Mm-hmm.
Okay.
Yeah.
And you didn't say anything for number 1 sample question. So are you gonna ask us to sketch 2 distinct
I
isotopes?
already did that. So this is the one.
Oh, the one we did at the helium. Yeah.
Yeah.
With the protons and neutrons and everything,
Yeah.
right?
Right. Yeah.
Okay.
The number of the neutrons is different. Yeah.
Okay, sounds good. Thank you.
Okay. Great. All right. Heat transfer, conduction, convection, radiation. Can you give an example for each one of them? We give you a couple of the sample example, right? So let's say if you use your hand touch to a hot cup of coffee, what is the way that you do a heat transfer? Oh, well, you have direct contact with the cup, it's going to be the conduction. If you turn on the fan, it's going to blow air, and the air is going to give you, take away the heat, and that's what we call the convection. The radiation is that if you go outside and you feel warmer, and if you're under the shade, you're going to feel colder, because when you go outside under the sun energy is radiated to you, so you feel the radiation energy. Where you're under the shade, you are not going to receive the sunlight, and it's not going to give you the radiation energy. So there's a lot of examples that you can give. Just think about how the energy is transferred through different ways. So convection is the motion of the fluid. Conduction is direct contact. Normally, it's direct contact of the solid. And radiation is the wave. It's normally just like the light, and then well, some of the energy is not like the light you can see. As long as an object has a temperature, it's going to radiate. Radiation meaning you can also receive energy. You can also release energy. Okay. The number 7, talking about the change of the phase. So liquid to solid. Are you going to add energy, or are you going to take energy away? You can think about liquid like a water, solid like an ice. When you wanted to make the water into an ice, you need to take away the energy. So you're going to take energy from it. Okay, so that's the answer for this one.
And
If you want to,
release energy, correct?
yeah, you need to release, you need to take away the energy.
Okay.
You need to take energy away.
Thank you.
You wanted to change from liquid to gas, which is from water to steam, then you need to add.
Condensation.
It's not condensation, it's
No?
vaporization.
Evaporation. Yeah, evaporation.
Yeah.
Thank you, cooling.
Mm-hmm.
The warming process is the one is condensation, correct, Dr. Leo?
Condensation is the other way, is from the steam become liquid.
The same. Thank you. I'm confused on that one. Thank you.
Yeah, I know so the warming and cooling process is totally opposite the energy that we're thinking about. So yeah, make sure that you understand the difference.
Thanks.
The distinguish among these abstract, I just draw the picture, so I'm going to skip this one. Any question about this? All right, I have a couple minutes. I'm going to go through this multiple choice question and give you the answer for each one of them. So let's look at the first one here. How does a molecule differ from an atom? So atom is just one single element. Molecule is a couple elements that you combine together. So, and the molecule also have a bond. So the answer for this is what? The answer is going to be the B. It's composed by 2 or more atoms and bound together. Okay, mixture doesn't have a bond, but molecule has a bond. Now the second question, if the mass of an object double and volume remain the same, what about the density? So density depends on the mass, and also the volume is proportional. Yeah, it's proportion to the mass. It's inverse proportion to the volume. So you double the mass, you're going to double the density. Right, number 3, why isn't there a horizontal buoyant force on a submerged object? So that is the situation I draw. If this is the water, then you have a submerged object over here. You're going to have a pressure from the bottom, pressure from the top. You also have a pressure from the sides. top and bottom are different. Sides are the same. Sides have the same
Again,
amount against each other. So what will be the answer for this? So the force factor on the sides cancel one another. So you don't moving right and left. You're only moving up and down because there's only difference on the up and down. The sideway are going to be the same. Okay, when water is turned on in a shower, the shower curtain move forward toward the water. So this has to do with what? What is the principle related to this? What is the principle related to a moving fluid?
I don't know.
It's the Bernoulli principle. So higher of the speed, the lower of the pressure, so the current will move toward to the water because water is flowing faster, will move the air around the water. So it will going forward to that. So it's what we call the pressure of the moving fluid. That's the Bernoulli principle.
Pressure of a moving fluid.
Okay. The next one, compared to a giant iceberg and a hot cup of coffee, which one has a higher temperature, which one has a higher internal energy? So hot cup of coffee certainly have a higher energy, a higher temperature, but it doesn't have a higher internal energy because it depends on the mass and also the temperature. A giant iceberg certainly has a huge amount of the mass. So it has a higher temperature, but less of internal energy. Okay, number 6, you feel warmer on a rock than a tile floor because the rock is what? It's an insulator than a tile, so you feel different. Just the same that you touch to the wood and touch to a metal. So a wood is an insulator, so you don't feel colder and you feel warmer for the wood because wood is a good insulator than the metal. Number 7, when you have a solid change to liquid, the solid will release or absorb. It's going to absorb energy. Solid is like ice, change to liquid to water. You need to absorb energy. All right, number 8. Wow, this is a little like testing your calculation, but it's not like a very complicated calculation. So 60 vibration per second. What does this number tells you? Is it a frequency or period? That means 16 cycles per second. That is actually tells you the 60 hertz. This is a frequency. It travels 30 minutes in 1 second. This 30 minutes in 1 second meaning how fast, how slow it's moving. So it tells you actually the speed of this wave is 30 minutes per second. So this tells you the wave speed. And the top one tells you the frequency. Therefore, the answer for this should be
B.
B. I don't know why I put a B at the bottom, but yeah, this is the answer.
Yeah.
The answer is really D.
Yeah, it should be, wow, I don't know what happened. But that's 60 hertz and the speed is 30 meters per second. Okay. Number 9, Doppler effect occur when a source of the sun move. Which one? Is it away or toward, or either? Well, it happened on both ways. So when you go toward, the frequency is increasing. When you go away, it's going to decreasing. But those both of the thing is counted as Doppler effect. So either toward or away. Okay, the last one, the sound wave is a longitudinal wave. Okay, it's a longitudinal. Transverse wave is this kind of wave. This is a transverse. This is a transverse. All right. Longitudinal will be like this. This will be more like longitudinal. Okay, I finished the review. Do you guys have any question?